So today we are going to kind of round out our skills with rational expressions and focus on adding and subtracting them. We've written them in simplest form or lowest terms. We've multiplied and divided with them. Now we're going to add and subtract with them. And it's going to be very similar to how we add and subtract with. Uh, so we are going to handle rational expressions the same way we do fractions. If you recall, if we have, say, a fraction that is 2/3 and we add it with another fraction that, let's call it 1/3. Okay. If the denominators are the same, we can simply keep the denominator at 3 and add up the top. So 2 plus 1 up top over 3, and that would give us 3 over 3, which if you wanted to, you could then simplify down to 1. So no need to write that down anywhere on your paper. But just remember that, hey, we're going to handle rational expressions the same way we do fractions. So let's see how this comes into play with example 1. We have x over 4 plus 7x over 4. So our denominators are the same. We check them out, see that, okay, both these fractions are over 4. So we're simply going to keep our denominator the same and add up x plus 7x up top. And if it helps you to think about having a 1 out in front of that x, that might be good to write in. So we'll get 8x over 4. Reminder that we're not doing anything with the exponents, right? We're combining like terms. We're simply adding them up. 1 plus 7 gives me 8. And we'll get 8x divided by 4. Let's check and see if we can simplify that any further by expanding stuff out. 2 times 2 times 2 times x over 2 times 2. Looks like there's a couple of 2's I can cross out here if I wanted to. And so my final answer would be 2x over 1, or simply 2x. Okay, let's start trying this on your own. For example 2, 8x squared over 5x minus 3x squared over 5x. Addition and subtraction don't change anything. We just want to check and see if the denominator is the same. Go ahead and pause your screen and try this on your own, and then come back and check it against my work. Since we do have the same denominator, okay, we can keep that at the bottom, and we can simply handle the subtraction problem up top. 8x squared minus 3x squared over 5x. That will give us 5x squared over 5x. And then if we want to rewrite this in lowest terms at the end, we can expand it out and cancel 5 times x over 5 times x. Which gives us, cross out the 5's, cross out a pair of x's. We're just left with x up top, which means that our final answer is simply x. And let's try this again with one more example here. We have 4x plus 5 over 3 minus 2x over 3. Go ahead and pause your screen to try this, but pay attention to combining like terms. We can't combine them if they're not like terms. Remember that. So the denominator is the same. Everything's going to be over 3 for this example. We'll have 4x plus 5 minus 2x. Okay, and let's remember that the 4x and the 2x minus 2x are like terms here, so we can combine them together. We'll have everything over 3 still. We'll have 2x plus 5. And we're going to stop there because we can't combine the 2x plus 5. They are not like terms. And if we check and try to see if we can simplify anything down to lowest terms, we really can't, because there's not going to be any common factors between the 3, the 2, and the 5. So we can leave our problem as is right there. So far in our examples, we've been fortunate enough to deal with rational expressions that have the same denominator. But oftentimes we'll see rational expressions that have different denominators. All right, we'll quickly see it in example 1. And so when that happens, we need to use a formula to make our denominators the same, allow us to add and subtract the fractions. And we'll see we can use this formula up top here to accomplish that. So if we get a fraction, a over b plus c over d, we can rewrite that expression into one single fraction by doing a times d plus b times c up top, and in our denominator we'll have b times d. It's a lot easier to see how this plays out in an example. Let's do it with example 1 right here. We have 3 over 5 plus 1 over x. In this case, 5 and x are denominators. Those are different things. So let's, if it helps for this example to write in what our different letters are, we can do that. So let's go here, and I'm going to write in, hey, okay, A is that 3, B is that 5, C is that 1, and D is that x. So if I label those and then use this formula here to rewrite our expression, we'll have a times d, so we'll have 3 times x, plus we'll have b times c, so we'll have 5 times 1, all over b times d on the bottom, which is 5 times x on the bottom. So that'll give us, if we carry this out, 3 times x is 3x, plus 5 times 1 is 5, all divided by 5x on the bottom. And in this problem, we can stop there. That's it. We've simplified it as much as we can. We can't combine 3x and 5. They're not like terms. And there's no common factors between our denominator and our numerator, so we can't simplify this any further. Let's go ahead and try this on a new problem, example 2. Go ahead and pause your screen and try it for yourself. Check it against my work. If it helps you to label all the different items, A, B, C, and D, let's do that. A, B, C, D. And 4x and 2x are not the same denominator, so we'll have to use this formula in order to calculate this. We'll get 5 times 2x up top. This time it'll be minus, because we have that minus sign in the middle there. Minus 4x times 1, all divided by 4x times 2x. Okay, and then we work through and try to simplify everything. We have 10x minus 4x, all divided by 8x squared. Now, if you can get to this point here, that we got 10x minus 4x divided by 8x squared, great. That gets us a bulk of the way there. We do want to continue to practice getting things in the simplest form, however. So we want to see if there's any common factors that show up with all of our terms. We'll notice that there is definitely some that we can factor out. So what I'm going to do is kind of show you those steps, just so you get exposure to this in this problem. If I rewrite everything with expanded terms, so let's go 2 times 5 times x. The first one minus 2 times x. The second one, that's all over 2 times 2 times 2 times x. Okay, we'll notice that we have some things that we can cross out. So let's first factor out the greatest common factor up top. So we'll factor out a pair of 2 and x and kind of rewrite our problem. Actually, I should back up here. Ignore what I just did. I'm noticing now that I didn't really simplify out the problem that we had there. We have 10x minus 4x up top. We have like terms that we can combine, right? We have 10 of something minus 4 of something. That's going to leave us with 6 of that thing up top. So we'll end up with 6x divided by 8x squared. And this makes it a lot easier for us to simplify, right? We can expand it out to 2 times 3 times x up top, over 2 times 2 times 2 times x on bottom. Cross out a set of 2's, cross out an x, and be left with 3 over 4x as our final answer. All right, last problem here. I want you guys to see it so that you have exposure to this difficulty of problem. Notice how we have a binomial down in the denominator of our second term. So if it helps us to label our different areas, let's go ahead and do that. We have A, B, C, and D. Okay, and we'll use our formula to help us with handling the different denominator problems. So we'll have 3 times d, which d is going to be all of x plus 2. So let's write that in parentheses so we make sure we handle all of it. Plus 4 times 1, all divided by 4 times, again, x plus 2. Let's again use parentheses there to help us out. Now, when we simplify this, let's remember to distribute in so that we can appropriately handle those parentheses as we do those problems. So the first thing we're going to get is 3x plus 3 times 2 gives us 6. And then we'll just be left with plus 4 up top. And on the bottom, we'll get 4x plus 8. Then we go through, we see if there's any like terms we can combine. In this case, we have 3x plus 6 plus 4, which would give us 3x plus 10. And we have 4x plus 8 on the bottom. There's no common factors that we can take out, so we're just going to leave our answer like this.